Now we are on to reading section, test 2 IELTS 8 student group, and this is about glass manufacturing. And before we go ahead, let me show you the questions being asked. It is always better to go through the questions because the questions will tell you what you have to extract from the passage, and these are the questions. And I would strongly recommend you to stop here or to pause and read it once before we start reading the passage. So I hope you have gone through this content or the questions. Let me read it for you. Sheet glass manufactured the float process. Glass which has been made since the time of Mesopotamians and Egyptians a little more than a mixture of sand, soda ash and lime. When heated to about 1500 degrees centigrade or Celsius, this becomes a molten mass that hardens when slowly cooled. The first successful method for making clear flat glass involves spinning. This method was very effective as the glass had not touched any surface between being soft and becoming hard, so it stayed perfectly unblemished with a fire finish. However, the process took a long time and was labor intensive. Nevertheless, demand for flat glass was very high and glassmakers across the world were looking for a method of making it continuously. The first continuous ribbon process involved squeezing molten glass through two hot rollers similar to an old mangle. This allowed glass of virtually any thickness to be made non-stop, but the roller would leave both sides of the glass marked, and this would then need to be grounded and polished. This part of process rubbed away about 20% of the glass, and the machines were very expensive. The float process for making flat glass was invented by Alistair Pilkington. This process allows the manufacture of clear, tinted, and coated glass for buildings and clear and tinted glass for vehicles. Pilkington had been experimenting with improving the melting process, and in 1952 he had the idea of using a bed of molten metal to form the flat glass, eliminating altogether the need for rollers within the float bath. The metal had to melt at a temperature less than the hardening point of glass, that is 600 degrees centigrade, but could not boil at a temperature below the temperature of the molten glass, that is 1500 degrees centigrade. The best metal for the job was tin. The rest of the concept relied on gravity, which guaranteed that the surface of the molten metal was perfectly flat and horizontal. Consequently, when pouring molten glass onto the molten tin, the underside of the glass would also be perfectly flat. If the glass were kept hot enough, it would flow over the molten tin until the top surface was also flat, horizontal, and perfectly parallel to the bottom surface. When the glass cooled at 604 degrees centigrade or less, it was too hard to mark and could be transported out of the cooling zone by rollers. The glass settled to a thickness of 6 millimeters because of the surface tension interactions between the glass and the tin. By a fortunate coincidence, 60% of the flat glass market at the time was 6 millimeter glass only. Pilkington built a pilot plant in 1953, and by 1955 he had convinced his company to build a full-scale plant. However, it took 14 months of non-stop production, costing the company $100,000 a month before the plant produced any usable glass. Furthermore, once they succeed in making marketable flat glass, the machine was turned off for a service to prepare it for years of continuous production. When it started again, it took another 4 months to get to the process right again. They finally succeeded in 1959, and there are now float plants all over the world, with each able to produce around 1,000 tons of glass every day, non-stop for around 15 years. Float plants today make glass of near optical quality. Several processes, melting, refining, and homogenizing, take place simultaneously in the 2,000 tons of molten glass in the furnace. They occur in separate zones in a complex glass flow driven by high temperatures. It adds up to a continuous melting process lasting as long as 50 hours, but that delivers glass smoothly and continuously to the float bath, and from there to coating zone, and finally to heat treatment zone, which stresses formed during cooling are relieved. The principle of float glass is unchanged since 1950s. However, the product has changed dramatically from single thickness of 6.8 mm to range from sub-millimeter to 25 mm, from a ribbon frequently marked by inclusions and bubbles to almost optical perfection. To ensure the highest quality, inspection takes place at every stage. Occasionally, a bubble is not removed during refining, a sand grain refuses to melt, a tremor in the tin put ripples into the glass ribbon. Automated online inspection does two things. Firstly, it reveals process faults upstream that can be corrected. Inspection technology allows more than 100 million measurement a second to be made across the ribbon. Locating flaws the unaided eye would be unable to see. Secondly, it enables computers downstream to steer cutters around flaws. Float glass is sold by square meter, and at the final stage, computers translate customer requirements into patterns of cuts designed to minimize waste. Now we have just gone through the content, and let us now try answering. Early method of producing flat glass method was spinning. SG, I'll write a short form of this. Glass remained blemished. BD. The disadvantage is and slow and labor intensive. Labor intensive. Then came the ribbon method, could produce glass sheet of varying thickness. Non-stop process. Glass was means glass was marked. That is why 20% of the glass rubbed away. Machines were expensive. This is Pilkington float process. We have this molten zone. The six is actually our glass. The 7 is nothing but tin or metal. You can write tin or metal. Tin will be good because tin is mentioned here in the content. And then these are the rollers. ROLLERS. Then from 9 to 13, we have to find out whether these statements are true, false, or not given according to the passage. So the metal used in the float process had to have specific properties. 9, this is true. That is why 10 is chosen. Pilkington invested some of his own money in his float plant. 10. This is not given, though it was given that 100,000 was every month it was spent. Then Pilkington's first full-scale plant was an instant commercial success. 11. And this is false. It took a long time and a lot of money to become a commercial success. Then the process invented by Pilkington has now been improved. 12. This is true because now you can get glass of various thicknesses, sub-centimeter to 25 millimeter. Computers are better than humans at detecting faults in glass. 13 is true, which a human eye or perfectionist cannot find out. So now we are on to reading passage 2. Again, we have to, see and learn those passage and then try to answer these queries. These are from 14 to 28. What we have to do is these are the list of headings, and what headings can be assigned to the content of the passage is like this. Like paragraph A will match with 8. Paragraph A is people having or have always responded to climate change. And then for paragraph C, we can assign how past climate conditions can be determined. So you have to read it very carefully and try to assign 14, 15, 16, 17, that is B, D, E, F, some sort of headings which will be clear after reading. And after completion of this little ice age, we'll try answering these questions from 18 to 22. All these options are given and we have to choose. So let us go ahead and read it. So this book the topic is the Little Ice Age. This book will provide a detailed examination of the Little Ice Age and other climate shifts. But before I embark on that, let me provide a historical context. We tend to think of climate as opposed to weather as something unchanging, yet humanity has been at the mercy of climate change for its entire existence, with at least 8 glacial episodes in the past 730,000 years. Our ancestors adapted to the universal but irregular global warming since the end of the last great ice age around 10,000 years ago with dazzling opportunism. They developed strategies for surviving harsh drought cycles, decades of heavy rainfall, or unaccustomed cold, adopted agriculture and stock raising, which revolutionized human life and founded the world's first pre-industrial civilization in Egypt, Mesopotamia, and the Americas. But the price of sudden climate change in famine, disease, and suffering was often high. Then B, the Little Ice Age lasted from roughly 1300 until the middle of the 19th century. Only 2 centuries ago, Europe experienced a cycle of bitterly cold winters. Mountain glaciers in the Swiss Alps were the lowest in recorded memory, and the fact ice surrounded Iceland for much of the year. The climate events of the Little Ice Age did more than help shape the modern world. They are the deeply important context for the current unprecedented global warming. The Little Ice Age was far from a deep freeze, however, rather an irregular seesaw of rapid climate shifts. Few lasting more than a quarter century, driven by complex and still little understood interactions with the atmosphere and the ocean. The seesaw brought cycles of intensely cold winters and easterly winds. They switched abruptly to years of heavy spring and early summer rains, mild winters, and frequent Atlantic storms, or a period of droughts, light northeasterly winds, and the summer heat waves. C. Reconstructing the climate changes of the past is extremely difficult because the systematic weather observation began only a few centuries ago in Europe and North America. Records from India and tropical Africa are even more recent. By the time before records began, we have only proxy records reconstructed largely from tree rings and ice cores, supplemented by a few incomplete written accounts. We now have hundreds of tree rings records from throughout the northern hemisphere and many from south of the equator, too amplified with a growing body of the temperature data from ice core drilled in Antarctica, Greenland, and Peruvian Andes and other locations. We are close to knowledge of annual summer and winter temperature variations over much of the northern hemisphere, going back 600 years. Now, this book is a narrative history of climate shifts during the past 10 centuries and some of the ways in which people in Europe adapted to them. Part 1 describes the medieval warm period, roughly 900 to 1200. During these 3 centuries, Norse voyagers from northern Europe explored nether areas or seas, settled Greenland, and visited North America. It was not a time of uniform warmth, for then, as always since the Great Ice Age, there were constant shifts in rainfall and the temperature. Mean European temperatures were about the same as today, perhaps slightly cooler. It is known that the Little Ice Age cooling began in Greenland and the Arctic in about 1200. As the Arctic ice pack spread southward, Norse voyages to the west were rerouted into the open Atlantic, then ended altogether. Storminess increased in the North Atlantic and North Sea. Colder, much wetter weather descended on Europe between 1315 and 1319, when thousands perished in the continent-wide famine. By 1400, the weather had become decidedly more unpredictable and stormier, with sudden shifts and low temperature that culminated in the cold decades of the last 16th century. Fish were a vital commodity in growing towns and cities where food supplies were a constant concern. Dried cod and herring were already the staple of the European fish trade, but changes in water temperature, forcing fish fleets to work further offshore. The Basques, Dutch, and the English developed the first offshore fishing boats adapted to a colder and stormier Atlantic. The gradual agricultural revolution in northern Europe stemmed from concern over food supplies at a time of rising populations. The revolution involved intensive commercial farming and the growing of animal fodder on land not previously used for the crops. The increased productivity from farmland made some countries self-sufficient in grain and livestock and offered effective protection against famine. Then F. Global temperatures began to rise slowly after 1850, with the beginning of the modern warm period. There was a vast migration from Europe by land. Hungry farmers and others to which the famine caused by the Irish potato blight contributed to North America, Australia, New Zealand, and Southern Africa. Millions of hectares of forest and woodland fell before the newcomers' access between 1850 and 1890, and intensive European farming methods expanded across the world. The unprecedented land clearance released vast quantities of carbon dioxide into the atmosphere, triggering for the first time humanly caused by global warming. Temperatures climbed more rapidly in the 20th century as the use of fossil fuels proliferated and greenhouse gas levels continued to soar. The rise has been even steeper since the early 1980s. The Little Ice Age has given way to new climate regime marked by prolonged and steady farming. At the same time, extreme weather events like Category 5 hurricanes are becoming more frequent. So now let us answer. We have just gone through the Little Ice Age. So here are the headings, and we are trying to link it or assign it to the paragraph. So this paragraph B, if you go through it, this was paragraph B, and you can pause and just read it once again. This will have a heading. The best heading would be the relevance of the Little Ice Age today. So this would be 2. Then paragraph D, if you go through D again, this is what it was. So please read it once again, and we'll try to provide the heading. So paragraph D will be our 7th, a study covering 1,000 years. This would be VII. That is the 7th one. Now paragraph E, if you go through paragraph E, this was about food and fish trade and livestock, etc. So this would be our enough food at last, right? So this will be 9th. And paragraph F, the final one, was this, right? How it all started and global warming, etc. So F would be our IV, human impact on the climate, right? IV. That is the 4th one. Now let us go ahead and try answering these questions 18 to 22 based on the Little Ice Age. So documentation of past where the condition is limited. Our main source of knowledge of condition in the distant past are, what are the answers? We have to choose it from this, right? So these are ice cores, and and tree rings. We can deduce that the Little Ice Age was a time of dash, a time of climate shifts, rather than of consistent freezing. Within it, there were some periods of very cold winters, others of storms and heavy rain, and yet others that saw dash with no rain at all. 22 would be our G, heat waves. So now 23 to 26, classify the following events as occurring during the medieval warm period, Little Ice Age, and modern warm period. 23. Many Europeans started farming abroad. 23. And this is C. The cutting down of tree began to affect climate. Again C. European discovered other lands. 25. And that is medieval warm period. And changes took place in fishing patterns. And this was Little Ice Age. Right? Now finally to the passage here, which we are going to answer from 27 to 32, and also we have 32 to 36 and 37 to 40. Right, we have question from 27 to 40 we have to answer, so we have to read it very carefully because there are a lot of questions. And first is again assigning the headings. So let us start and read. The meaning of power of smell. The sense of smell or olfaction is powerful. Odors affect us on physical, psychological, and social level. For most part, however, we breathe in the aromas which surround us without being consciously aware of their importance to us. It is only when the faculty of smell is impaired for some reason that we begin to realize the essential role of sense or smell plays in our sense of well-being. A. A survey conducted by Anthony Synott at Montreal's Concordia University asked participants to comment on how important smell was to them in their lives. It became apparent that smell can evoke strong emotional responses. A scent associated with a good experience can bring a rush of joy, while a foul odor or one associated with bad memory may make us grimace with disgust. Respondents to the survey noted that many of their olfactory likes and dislikes were based on emotional associations. Such associations can be powerful enough so that the odors that we would generally label unpleasant become agreeable, and those that would generally consider fragrant become disagreeable for particular individuals. The perception of smell therefore consists of not only for the sensation of odors themselves, but the experiences and the emotions associated with them. Then B is odors are also essential cues in social bonding. One respondent to the survey believed that there is no true emotional bonding without touching and smelling a loved one. In fact, infants recognize the odors of their mother soon after birth, and adults can often identify their children or spouses by scent. In one well-known test, women and men were able to distinguish by smell alone clothing worn by their marriage partners from similar clothing worn by other people. Most of the subjects would probably never have given much thought to odor as a cue for identifying family members before being involved in the test. But as the experiment revealed, even when not consciously considered, smells register. In spite of its importance to our emotion and sensory lives, smell is probably the most undervalued sense in many cultures. The reason often given for the low regard in which smell is held is that in comparison with the importance among animals, the human senses of smell is feeble and undeveloped. While it is true that the olfactory powers of humans are nothing like as fine as those possessed by certain elements, they are remarkably acute. They are still remarkably acute. Our noses are able to recognize thousands of smell and to perceive odors which are present only in extremely small quantities. Smell, however, is a hugely elusive phenomenon. Odors are like colors, for instance, cannot be named in many languages because the specific vocabulary simply doesn't exist. It smells like and you'll stop. We have to say when describing an odor struggling to express our olfactory experience. Nor can odors be recorded. There is no effective way to either capture or store them over time. In the realm of olfaction, we must make do with descriptions and recollections. This has implications for olfactory research. Then most of the researchers are on smell undertaken to date has been of physical scientific nature. Significant advances have been made in understanding of the biological and chemical nature of olfaction, but many fundamental questions have yet to be answered. Researchers had still to decide whether smell is one sense or two responding to odors proper and other registering odorless chemicals in the air. Other unanswered questions are whether the nose is the only part of the body affected by odors and how smells can be measured objectively given the non-physical components. Questions like these meant that interest in psychology of smell is inevitably set to play an increasingly important role for researchers. However, smell is not simply a biological and psychological phenomenon. Smell is cultural and it is a social and historical phenomenon. Odors are invested with cultural values. Smells that are considered to be offensive in some cultures may be perfectly acceptable in others. Therefore, our sense of smell is a means of and a model of interacting with the world. Different smells can provide us with intimate and emotionally charged experience, and the value that we attach to these experiences is interiorized by the members of society in a deeply personal way. Importantly, our commonly held feelings about smells can help distinguish us from other cultures. The study of cultural history of smell is therefore, in a very real sense, an investigation into the essence of human culture. So now let us first assign the paragraphs, the heading. So paragraph A would be our smell is our superior sense, 7. Then we have paragraph B, which was the role of smell in personal relationship. Then 29th was paragraph C, and this is 29, so this was about why our sense of smell is not appreciated. Then D was about 30 was the first one. The difficulties of talking about smells because there is no vocabulary. E, that is 31, is or it matches with 3. Future studies into smell, researching. And finally F, the F was 32, and this is our the interpretation of smells as a factor in defining groups and community, interacting with the world. Now choose the correct letters ABCD, write the correct letters. First, 33. According to the introduction, we become aware of the importance of smell when we discover a new smell, experience a personal smell, our ability to smell is damaged. We are surrounded by odors. 33. And the answer is our ability to smell is damaged. 33. Because it is still underdeveloped. 34. The experiment described in paragraph B. The experiment, let us see. So the experience or experiment of social bonding. So mothers and infants find mother and the partners. People can find their partner, men and women. So 34, and this was actually A. Show how we make use of smell without realizing it. 35. What is the writer doing in paragraph C? Again, let us go to paragraph C. So in spite of its importance in emotional and sensory life, smell is probably the most undervalued sense because we can easily find it, but animals have uh, these developed more. So let us try to answer it. 35. 35 is actually C, rejecting a common belief. 36. What does the writer suggest about the study of smell in the atmosphere in paragraph E? So paragraph E is this. So most of the research on smell undertaken to date has been physical significant nature, right? And there need to be an objective answer. All these were given, so you can read it just now. So this was 36 was smell is not yet been defined. There has to be an objective method. Now 37 to 40, the final one, choose one word only. You have to choose only one word and otherwise your marks will be deducted. 37. Tests have shown that odors can help people recognize the dash belonging to their husbands and wife. 37. Clothing. Certain linguistic groups may have difficulty describing smell because they lack the appropriate vocabulary. The sense of smell may involve response to dash which do not smell in addition to obvious odors. 39 is chemicals. Odors regarded as unpleasant in certain dash are not regarded as unpleasant in others. These are cultures or communities. Cultures will be good. So this was our reading test 2 IELTS 8. Thank you so much. Take care.